Hey there. I will be uploading more videos on IB Physics in this channel, and I'll really appreciate if you can point out my mistakes as well as if you can subscribe so we can stay in touch.
Hello guys, today I would like to discuss 2022 May SL paper 1 multiple choice paper. I will answer all these 30 questions, and through that you will be able to gauge your answers and fix your mistakes. Alright, first question is about the area of a circle with its area of the area. The area of a circle is pretty simple. Area is pi r squared. You are not given a calculator, so you should do the calculations by yourself. 3.14, radius is 10 squared, you will get 314 square centimeters. The confusing part is how to find the area of the area. Again, I write the same equation. Delta A over A is plus or minus. We know this 2 will come to the front, right? So 2 delta R over R. Then you may ask what happened to this pi. Pi is a multiplication constant, so that disappears. So delta A equals plus or minus 2 delta R over R times pi R squared. So 2 delta R over R times pi R squared. So this one cancels this one, right? So the final answer will be plus or minus 2 pi R delta R, which is 2 3.14 10 times 0.5. If you look at these two numbers, this is half and 2, so they cancel out. So you will get 31.4 square centimeters. So area altogether you can write 314 plus or minus 31. So answer will be D. Alright, question number 2. This is about proving a directly proportional. So first there are two things we have to understand. What is directly proportional? Why is directly proportional? Graphically, this means there should be a straight line. It must go through the origin, right? We know 0, 0 point is called the origin. Now let's draw the best fit line for these two situations. Best fit line is somewhere in between these maximum and minimum lines, right? So if you look at these two, we can see these two lines actually, or the best fit line has been shifted, right? So this shows a systematic error. All the readings are moved to one side, but this one does not have a systematic error on the Q. But the problem in Q is, if you look at the uncertainty of gradient, let's say this is maximum lines gradient, and this is best fit line gradient, right? So this one has this gradient minus this gradient, that is pretty big compared to P, where gradient is almost similar to each other, right? So the Q has a problem, larger uncertainty in gradient. They have two different problems. P has a systematic error, the graph has moved to one side, and Q has more scattering of the points, so the uncertainty of the gradient is larger. So answer is C. Question number 3. Now if you go from point X to Y, your displacement is in this direction, right? But if you look at the same thing from Y to X, hold on, Y to X, the gradient is the displacement is minus 800, right? Distance on the other hand is distance. You go this way or you go this way, same length of the path, so distance does not change. So this question, distance has to be the same, but displacement has to, as the direction has reversed, it has to be minus 800. So answer is D. Question number 4. Here we are discussing about a distance traveled or displacement made if it is a velocity time graph, right? So basically we have to find the area of these two parts, right? Area 1, it's a triangle, right? Area 1 is, it is the height and base divided by 2, right? So this is VT1, so VT1 over 2. Area 2, this is a rectangle, so V times this time, the time here is T2 minus T1, so V times T2 minus T1. So total area is A1 plus A2, you will get VT1 over 2 plus VT2 minus T1. Let's see whether they have given this answer. Definitely answer is D. Question number 5. Here you want, the tricky part is you need to know what is the distance this block travels within the second, not from 0 to 2, 1 second to second, in that duration how far it goes. Second problem we have here is if it is falling under gravity, acceleration is 9.81, but here it is sliding down in an inclined plane, we don't know the acceleration. So we have to determine the acceleration if you want to find the distance traveled. So what I do is time equals 0 seconds to time equals 1 second, I write into along the inclined plane s equals ut plus at squared over 2. Let's see what I am trying to do. And the distance is given for the first second. 1 equals starting from 0. How do I know it is starting from 0? The keyword is sliding from rest. Rest shows the idea initial speed is 0. So acceleration we don't know. Time for this motion is 1 second. So 1 squared over 2. Acceleration you will get as 2 meters per square second. Now we are ready. Now what I do is time equals 0 to time equals 2 seconds. I am thinking about this motion. I do the same. S equals ut plus at squared over 2. Let's say S equals starting speed is 0, acceleration 2, time is 2 seconds over 2. You will get 4 meters. Now be careful. This is not what we are looking for. We are looking for time equals 1 second to time equals 2 seconds. So this displacement is you travel 4 meters from 0 to 2, you travel 1 meter from 0 to 1, so the difference is 3 meters. Answer has to be C. This question is also coming from mechanics. Topic number 2, mechanics. It's about friction. I try to plot the situation again here. This is a free body diagram of that block. It has 10 Newton forward, net force is 6 Newton, so definitely friction has to be 4 Newton backwards, right? What else do we know about friction? We know there's an equation about friction, F equals mu times R. R stands for the contact force. Very good. In this situation, R is mg. So I can change this equation. F we know F is 4 equals mu R is mg means 20. Here G we should be taking as 9.81 meters per square second, but I made it simple by taking as 10. So mu is 4 divided by 20. You will end up 0.2. Hold on. Mu is the frictional coefficient. It does not have units, right? So acceleration should be, acceleration we did not find. Okay, I am going back. I write F net equals ma. Net force is 6, mass is 2, acceleration is 6 over 2, 3 meters per square second. Now we have this answer, this one. So acceleration is 3, frictional coefficient is 0.2. Answer is A. Question number 7. The thing is, we are always focused on our rocket, what happens to it, what are the forces acting on the rocket, but what we are not focused is the reaction forces of these two forces. So let's think one by one. This one is the weight of the rocket, right? Who pulls the rocket down? The earth. So earth will have same force. See, I am using the same color, blue color, same size. So this is from rocket on earth is mg. You can say, why we don't ever mark this? Because we don't care what happens to the earth or what happens to the air. We care about our object, the rocket. Now let's think about the other one. Now rocket has a thrust. It is bigger than mg, that's why it is marked as a longer arrow, right? Now where does this come from? Who gives this force? Because we push the air down, so air pushes us upward. So we should have the same force on the air, surrounding air of the rocket. This comes from the rocket on exhaust air or the air surrounding the rocket. So these are the two forces missing in this picture for the completion. So let's think about F1. F1 is the force from the air on the rocket. So we should say F1 is the force of rocket on exhaust gases. That's right. So answer has to be A or B. The F2 has to be force of gravitational force of the rocket on the earth. So answer has to be B. Question number 8. Now this question looks difficult, but actually it is not, because this object has a 100 Newton force, and in 2 meters it gets into the speed of 10 meters per second, right? So what we do is work done on object will convert into kinetic energy of object, right? That's the idea. Okay, work done, we know work done is force times distance. Force times distance will change into kinetic energy equation, half mv squared. Very good. So force is 100, distance is 2, half, mass we don't know, speed at the end is 10 squared. It has to be squared, right? Now this looks difficult to do the calculation, but look, this 10 squared means 100, and this one cancels. Now m equals 2 times 2, 4 kilogram, right? So this answer has to be B, boy. Question number 9. 2 blocks of different masses. This question seems very confusing, but again this is also conservation of energy. When you compress a spring, and that spring has elastic potential energy, which when you release it changes into the kinetic energy of a mass. So elastic potential energy of spring changes into kinetic energy of mass, right? Now let's do the calculation for let's say for 1 kilogram mass. I write half kx squared. This is the equation for elastic potential energy. Half mv squared, right? This one cancels. V squared, V equals, if you look at this one, k over m times x is outside, right? So for 1 kilogram mass, spring constant 100, mass is 1 times 0.1. If you look at this one, you will get 1 meters per second. For 0.25 kilogram mass, here it is the extension is the same, spring constant is the same, only difference is mass. V equals, I am using this equation again, k 100, mass 0.25 times 0.1. Let's check this one. This is 400 square root times 0.1. This means 20 times 0.1, 2 meters per second. This is the speed of 0.25. Now your job is to not to mix up. Be careful when you find the answer. 1 kilogram mass should go at 1 meters per second. Okay, answer has to be this. 0.25 kilogram should go at 2 meters per second. So not this one. Answer is C. Question number 10. Now this is coming from topic 3.2, modeling a gas. One thing we have to understand is volume of a cylinder. Volume is cross-sectional area times length, right? In this situation, here it has been the piston has been pushed, so this volume is cross-sectional area is still the same, length has changed. And what else do we know? If the temperature is T, let's say this is T dash. If the pressure is here P, this has changed into 2P. They have given you this information. But very important thing they don't tell is number of molecules is number of moles is N. This is also N because gas cannot escape, right? Because it is sealed. Very good. Let's write PV equals nRT for first situation. So P pressure, V A times L equals N R T. This is the first equation, okay? PV equals nRT for second situation. Still it follows ideal gas equation, right? Pressure 2P, volume A times, now it is 5L over 6. Do you remember? Equals nRT dash. This is the second one. Now it is mathematics. What I do is 2, I come here, 2 over 1. So this one cancels. This is 3. 5 PAL over 3 divided by PAL equals nRT dash nRT. Now let's cancel as much as we can. PAL. So this ends up T equals or T dash equals 5 over 3 times T. Answer has to be C. Question number 11. They ask what is true for an ideal gas. This is from topic number 3, thermal physics. 3.2 is called modeling a gas. Now they ask which is true. Is this one, or this one, or this? The problem, it looks confusing, right? But actually, it's very simple question. What they ask is there are 3 variables: ideal gas constant, Avogadro constant, Boltzmann constant. These 3 constants, do you know how to combine these 3 together? That's the real question. Example, let's say PV equals nRT. Let's start from here. But we know number of moles is number of molecules divided by Avogadro number, right? So we can use this one here. So nRT is number of moles and number of Avogadro number R times T. Now let's focus on this one. If you can remember, R over Avogadro constant, example, this is 8.31, the Avogadro number 6.02 10 to the power of 23. If you divide, you will get Boltzmann constant, right? So actually this is Boltzmann constant, KB. B stand for Boltzmann. So nRT equals, instead of writing nRT, we can write N Boltzmann constant times T. So the answer is A, right? It's very straightforward and simple. Question number 12. Question number 12, they ask which assumption is part of the molecular kinetic model of ideal gases. Assumptions, like what is molecule, this is also from topic number 3, thermal physics. And assumptions you should remember. How do we imagine an ideal gas? We imagine a big container with very small, relatively very small size molecules going in different direction at different speed, completely random motion, right? This is an ideal gas in our imagination. So what are the assumptions? There are so many molecules, they have different speeds and collisions are elastic. So they ask which one is one of those assumptions. The work done on a system equals change in kinetic energy of the system. But that is called first law of thermodynamics, and it is not related to assumptions. The volume of a gas results from adding the volume of individual molecules. No, it is opposite. Volume is actually the most important volume is the volume in between molecules, not molecules itself. So this is also wrong. A gas is made of tiny identical particles at constant random motion. That's right. Like let's say carbon dioxide. All the molecules, carbon dioxide molecules are identical, but they have different speed. So this is right. All particles in a gas have kinetic and potential energy. Molecular potential energy happens only if they have intermolecular bonds. So this one does not exist for an ideal gas. So this is also wrong. So here the answer is C. All right. Question number 13 is also from thermal physics. It's based on this equation. Q equals mc delta theta, right? They talk about two systems. One is X, one is Y. And interesting thing is they both make, this one makes 10 Celsius difference, this one makes 10 Kelvin difference, but we know temperature difference wise Celsius and Kelvin are the same. Okay, example, let me give you an example. You can say 20 to 30 Celsius change, or you can say 150 Kelvin to 160 Kelvin. These temperature differences are exactly same. So when you look at this equation, we can see these two are the same. So we want to compare how much heat is given to each system, but we can't do that if we don't have information about mass or specific heat capacity. I repeat, we know this one is the same, but by change of temperature we can't tell anything about how much energy is given to each system. So answer has to be the we don't have enough information. Question number 14. This is about a simple harmonic motion. They are talking about maximum displacement. They want to compare velocity and acceleration. Let's think about simple harmonic motion. This middle point is called equilibrium point. These are extreme points, these two. So we are focusing on one of these. What do we know about simple harmonic motion that we learned in topic number 4.1 oscillations? We know here displacement is 0. We know here V is maximum. We know here acceleration is 0. But similarly, here x equals actually amplitude. Amplitude is maximum and velocity is 0. So this is the place we want to focus on. At extreme point, acceleration is maximum, velocity is 0. Maximum and velocity is 0. Answer is D. Question 15. Three statements about electromagnetic waves. Where did we learn electromagnetic waves? We learn electromagnetic waves in topic number 4, and then there is a bit about energy, how electromagnetic waves are produced. That is in 7.1 discrete energy. Alright, let's check. They can be polarized, yes, because electromagnetic waves are transverse waves. Transverse waves. Transverse waves can be polarized, so that's good. They can be produced by accelerating electric charges. That's very true. Think about in topic number 7, we understand when an electron falls from higher energy level to lower energy level, a photon goes out. These photons, as a collection of them, create a electromagnetic wave, right? So an electron has to accelerate to produce electromagnetic wave. So answer B is also right. They can be polarized, true. They can be produced by accelerating electric charges, true. They must travel at the same velocity in all media. No. Let me give you an example. Let's think about let's say light waves. In air, it can if of course travels at speed of light, 3 times 10 to the power of 8 in air. Let's think about water. Water, obviously, this can be 2 times 10 to the power of 8 meters per second. So they don't travel at the same speed in every medium. So this part C, third part is wrong. So now we can analyze. Answer has to be A. Question number 16. This is about again topic number 4, waves. Very important thing is we need to they are trying to check whether you understand the difference between displacement and time and displacement against distance graph. Displacement time graph is about a simple harmonic motion. Particle in a medium goes, let's say, left and right motion. From here what can we get? We can get peak to peak is the time of the oscillation. Similar displacement against distance graph is about whole medium. See, the particles are in different place. This is called displacement distance graph. From here also these 2 points are like, these are not peak to peak or trough to trough, but these two are also in phase points. So we can say this distance is lambda. Now about speed, v equals, we know the basic equation, right? But the basic equation for waves, v equals f lambda, but f equals 1 over t. So v equals lambda over t. Lambda we found is this rs. So rs, t is pq. This is the answer. Answer is C. Question number 17 is about refraction. Refraction is topic number 4. It's based on Snell's law. So a wave comes and bends or refracts in a second medium. It comes from glass to water. They ask what is the critical angle. Critical angle. Okay, in critical angle actually wave does not travel like this. Wave goes between the wave travels between two mediums like this. At that time r equals 90. Okay, let's write Snell's law. What is Snell's law? N1 sin I is N2 sin R, right? But here N1 is, hold on, 3 over 2 sine. This angle has a special name called critical angle. N2 is 4 over 3, sine R is 90. Okay, sine C is, I cross multiply, 8 over 9. So C equals sine inverse 8 over 9. Answer has to be D. Now let's go to question number 18. Question number 18 is about polarization. Again, polarization is from topic number 4. What do we know about polarization? They say 320 watt per square meter intensity. So this intensity is 320 watt per square meter. Now, first polarizer always makes intensity into half. So this intensity is 160, because 320 divided by 2 is 160 watt per square meter. Now this polarized light comes into the analyzer. Now this is 160 watt per square meter. Now how much comes out of this? I, it depends on this angle. They say angle is 30. Okay, now this is called Malus law. What is Malus law? Malus law says this equation, you remember, I equals I naught cos squared phi, right? So I equals I naught 160 cos squared 30. Okay, 160 cos 30 is square root 3 over 2 squared. So you will get 160 times 3 over 4, 120 watt per square meter. So answer is A. Question number 19 is about electric field. They say there's a charge Q here, and then there's a charge Q1 and Q2. Very important thing here is electric field strength is 0. Just see, net force is 0, or net electric field at on charge Q is 0. Now let's think the type of charges. Let's just imagine if this is positive Q, if this is negative, and if this is a negative charge, this one, left hand side one, will pull you, right? And right hand side also pull you. So to get force in opposite direction, they have to be similar type of charges. It does not have to be negative and negative, it can be positive and positive. So the charge, the sign of the charges should be the same. Answer has to be A or B. Now let's think about electric field strength equation. E equals K Q over R squared. Now let's look at the diagram one more time. Obviously this length is bigger, right? So if the length is bigger,
to get the same electric field strength, charge also has to be bigger, right? So whoever is further has to create the same electric field, so he must be bigger charge. So Q1 must be bigger than Q2, otherwise they can't cancel out each other. The answer is A. Question number 20. They talk about two situations. Same power supply, you connect into a one lamp, filament lamp, or two filament lamps. Now they want to know about potential difference across one lamp, this value, compared to this one. Then they want to know about total power of the power coming off the battery in first and second situation. Let's think about voltage. Example, I'll take this one as 12 volt. How much is this one? 12 volt. This is 12 volt also, because same situation, this will be only 6 volt, because these two lamps are identical. So obviously voltage has to, the potential difference across one lamp has to decrease. Now second thing, electric power has, you can write in three different ways: Vi, I squared R, or V squared over R, right? Now with experience you should know which one is the best to use. I can see the difference between these two circuits. There are similarities and differences. The total voltage of the circuit did not change. Resistance changed, because there's a one resistor, there are like two resistors. So assuming these are ohmic conductors, the filament lamps. But anyway, I can feel that we must be using this one, because we don't want to deal with current. Okay, so power equals V squared over R, right? But what happens if you don't change V, but if you increase R? This becomes twice, so this becomes half, right? So P dash will be P over 2. It means actually power, the energy coming out of the cell in a 1 second actually decreases in this situation. So power decreases, voltage decreases, power also decreases. So decrease, answer has to be A for the question number 20. Question number 21. This is about electric circuits. Topic number 5, electricity and magnetism. This question looks difficult because the way they have displayed the circuit. Let's draw it in a different way. There's 3 volt power supply, and then 1 ohm and 2 ohm, and 2 ohm and 1 ohm. These are two parallel branches of the circuit. Okay, now let's think this is 0 volt, right? This side is 3 volt, so this is 3 volt and this is 0 volt, right? Now we know we can use potential divider circuit equations to find. They ask what is the voltage between, let's say, this point and this point, 1 and 2. Okay, let's call this point A, this point B. So potential, let's find this potential difference. So VA equals, total is 3, and your resistance is 2 plus 1, so this will be 2 volt. Similarly, VB, this one is 3 times 1 divided by 2 plus 1 volt. So VA to B is 2 minus 1 volt. Now you can be confused. What if I take this one? If you take this one, this get 1 volt, right? But this is the potential difference. So it means if this is 3, this has to be VA is 2 volt. Still the same answers you will get. So the potential difference between A and B is 1 volt. Answer is B. Question 22 is also from topic 5, to be more exact 5.4, magnetic effects of electric currents. This question is based on Fleming's left hand rule. We know we can place our left hand, 3 fingers, middle finger, thumb finger and point finger perpendicular to each other, and middle finger will represent the current, thumb finger will represent the force, and point finger will represent the magnetic flux density. Alright, these are the things we know. Now they ask what is the force on SR. First let's check what is the direction of current in the circuit. Current goes from positive to negative, so it actually goes from S to R. Now use your left hand rule.
What I mean is magnetic field is in this direction, current is in this direction. If you check this one carefully, you will see the force is coming out of the page. Now what about ST? Let me erase other parts. We already explained this part. Now what about ST? There's a current, right? But magnetic field is this way. See, they are not perpendicular to each other. They are actually parallel. Parallel means no force. Force is zero. Force does not exist in this situation, because you know force is best if the magnetic field and the current are perpendicular, or at least in an angle. These two are in the same direction, so they are parallel, no force. So force should be the no force, so answer is B. Let's go to question number 23. They are talking about a satellite in the orbiting around the Earth. Okay, I was trying to draw Earth like this, and the orbit is this is my poorly drawn satellite, and it has a velocity in tangential direction, right? We know that word, tangential. Now let's try to mark all the forces. This one has G m over r squared. Capital M is the mass of the Earth, and small m is the mass of the satellite, and r is the radius of the orbit. All right. Now this is what actually we say mg force. Now the thing is, if the satellite is going in the orbit without falling down to the Earth, we can be sure m over r squared, or mg force, must be used for centripetal force, or to provide centripetal acceleration. Otherwise it has to either come down or go up if these two are not the same. So this is what we know. So it is equal to the gravitational force. They are talking about resultant force. Yes, resultant force is the gravitational force which provides centripetal acceleration. It is equal to the mass of the satellite multiplied by its acceleration. Yes, multiplied by its acceleration. Yes, mg. It is equal to the centripetal force of the satellite. This also right. So all answers are right. Answer is D. This is from topic number 6. Hold on. Okay, topic number 6 about Newton's law. 6.2 BK, more specific, Newton's law of gravitation. They say it can be used to predict the motion of satellite. Of course, because from Newton's law we even remember t squared equals 4 pi squared over gm times r3. We know the where will be the satellite according to the height. Everything can be predicted. This is a very powerful tool to predict about planets and the satellites. So this is good, and it explains why gravity exists. Nah, that's stupid. What I mean is, we know we have not even found in particle physics. We have photons, we have W and Z bosons, we have gluons, and very importantly we have gravitons. We have not even found graviton. It does not explain why this happens, it explains what happens. So this idea is wrong. It is used to derive an expression for gravitational potential. Let's think about gravitational potential, the work done in bringing a unit mass from infinity to a point. So g m r squared dr. Yes, so in this case 1 and 3 are correct, 2 is wrong. Answer is B. Question 25. They are talking about, remember, they are talking about electrons. Electrons were, and this is about topic number 7, particle physics. In topic number 7, there are 3 parts, so this is 7.3. Okay, to answer this question about electrons, we must know standard model. Let's think a bit about standard model. We know there are 6 quarks, up and down, charm and strange, top and bottom. There are 6 leptons, electron, muon, tau, 3 neutrinos, electron, neutrino, muon, neutrino, and tau neutrino. But these are not the point. Point is, there are 4 sets of bosons. One is photon. Photons is about electromagnetic force. Okay, and gluon is about strong nuclear force,
and this one is weak nuclear force. This is about gravitational force. Now leptons don't experience, remember, leptons don't experience strong nuclear force, and electromagnetic force, I mean, if it's an electron, of course it has charge, right? And weak nuclear force, they do experience. So electrons interact through virtual photons. It means what they ask is, do they have electrostatic force between them? Yes. Electrons interact through gluons. What they mean is, do they feel strong nuclear force? You should say no, because it is a lepton. Electrons interact through particles W and C. It means, do they experience weak nuclear force? You should say yes. So answer is 1 and 3. Answer has to be B. The energy levels of an atom are shown. How many photons of energy greater than 1.9 electron volt can be emitted from this atom? This is an energy level diagram. Okay. Let's think first how many photons we can produce. 1, 2, 3 from the first energy level, 4, 5 and 6. Now let's think about the smaller photons. Smaller means the energy difference is not much. Let's focus on randomly. Let's focus on this one, and let's focus on this one. Just check this one. First one, this one. So energy difference is delta E equals 1.5 minus 0.9. I don't care who is positive, who is negative. I am just finding the difference actually. So this is 0.6 electron volt. Okay, this is useful because we are looking for photons which are less than 1.9. Now let's think about this one. This one is 3.4 minus 1.5. Actually, this comes to 1.9 electron volt. This is on the threshold. This is still not more than 1.9. But if you check anything else, you will find everything else is more than 1.9 electron volt. So how many photons are possible? 1 here, 1 here, 2. So you should say answer. Hold on. They ask how many photons of energy greater? Okay, 2 are lower. There are 6 possibilities. So answer has to be 4, because 6 are all of them are, there are 6 photons and 2 of them are less than 1.9 electron volt. So more than 1.9 electron volt are 4. So answer has to be D. Question 27. Radioactive decay. They ask which statement is not true about radioactive decay. This is from topic number 7, atomic, nuclear and particle physics. The percentage of radioactive nuclei of an isotope in a sample of that isotope after 7 half-lives is smaller than 1%. Let's check. 1 half-life, 2, 3, 4, 5, 6, 7. Have a look. Now it has 1 over 128, means less than 1%. That's true. So first answer is correct. So it's not what we want. The half-life of radioactive isotope is the same time taken for half the nuclei in the sample of that isotope to decay. Of course, we know N naught becomes half, that is called half-life. So these are not the answers we are looking for. The whole life of radioisotope, hold on, the whole life of a radioactive isotope is the time taken for all the nuclei in a sample of that isotope to decay. Whole life, we never define whole life, we only define half-life. Why? Because we know the graph goes in a E minus T, like this shape graph. Actually it is an asymptote. So we can't talk about whole life, because whole life time whole will be infinite for any isotope, because it is an asymptote. It will never cut the line theoretically. So this idea is a wrong idea. We never even define whole life. The half-life of isotope range between extremely short intervals to thousands of millions of years. That's true. Like let's say uranium has 4.5 billion years, and like let's say I think lithium I think 3
has maybe 2 times 10 to the power of minus 6 seconds, very short. So what I mean is, yes, they have a range, so this is also correct. So the answer we are looking for is C. Question number 28. The age of the earth is about this many years. What area of physics provides an experimental evidence of this conclusion? See, before I told you uranium has this many half-life is 4.5 10 to the power of 9. First thing to understand is 4.5 10 to the power of 9 means, this means a billion. So it has 4.5 billion years. Let's just imagine you found a uranium breaks into thorium, okay? No, thorium or polonium, it doesn't matter. Uranium breaks into, let's say, yes, thorium. So you found a uranium 235 cube from the ground, and you find actually it is only 25% is uranium 235, and 75% is that thorium, polonium, any other, it has converted into other isotopes, okay? Now what can, and if you know the half-life of this one is 4.5 billion years, so what we can learn from this one, n naught becomes half n naught, becomes n naught over 4, becomes n naught over 8, right? Each is these steps needs half-life. So if you are here 25%, this obviously shows there are two half-lives. So time spent is 4.5 times 2 billion years, right? So you can say this is 9 billion years. So it means Earth age of the Earth, age of Earth must be more than this. So you can predict about the age of the Earth, right? Because it can't be less than 9 billion, because uranium has been around for 9 billion years, vice versa. But actually in this logic, that's how we found age of the earth is actually 4.5 billion years, coinciding with the half-life of uranium. Others are very useful, Newtonian mechanics, optics, electromagnetism, but they don't help us to understand the age of the earth. Photo means light, voltaic means voltage. So using the light of the sun, if you can produce voltage or electric energy, we call them photovoltaic cells. So the conversion here is solar energy into, in this case, photovoltaic cells, solar energy or light energy changes into electric energy. Now let's think about solar heating. Again, heating means directly it heats up. So solar energy changes into heat or thermal energy. So answer has to be A. Question 30. This is about topic 8, energy production. We know these diagrams, right? We have seen these. Now, filament lamp or LED bulb, we normally use bulbs or lamps to produce light, right? So useful energy here is only this portion. This part is actually wasted energy, wasted in a way that it converted into something that we don't need at this application. So here 2 and 1 2 3 4 5 6 7 8. So 2 out of 10 is good here. If you do the same 1 2 3 4 1 2 3 4 5 6, so 4 out of 10 is good with LED. Of course that makes all the sense, because filament lamps are being replaced everywhere by LED bulb. It must have a reason, right? The reason is the LED lamps are much more efficient in producing visible light. So this is 20% efficient, this is 40%, twice efficient. So filament lamp efficiency is 20, LED lamp is 40.